So, in the earlier lecture, I talked about the trapezoidal rule, Simpson's rule, whether it is 1/3 and the 3/8 rule. So, today I'm going to talk about that how these rules or formula can be used to evaluate the integral. So, here I want to evaluate an integral of sine x from 0 to pi, right? This is the integral which I want to evaluate using trapezoidal as well as Simpson's rule, whether it is 1/3 or the 3/8 rule. So first of all, let me recall these formulae, that how integral can be evaluated using trapezoidal rule. So integral can be written as 0 to xn, x naught to xn f of x dx. So formula for it is h by 2, it is f of naught plus 2f1 f2 and so on fn minus 1. This is a formula for it, plus fn. And then another integral using Simpson's 1/3 rule. According to it, x naught to xn or f of x dx, or it can be written as x naught to x3m 2m, because it is a multiple of 2 should be the number of intervals, and f of x dx, and it must be equal to h upon 3. Here it is f naught plus 4 times f1 plus f3, means all the odd terms, f5 plus and so on f2m minus 1, plus all even terms f2 f4 plus and so on f2m minus 2, and plus f of 2m. So this is the Simpson's 1/3 rule. Now let us talk about the Simpson's 1/8 rule. So according to 1/8 rule, 1/8 rule, integral can be x naught to xn, it is f of x dx, and it can be written as x naught to x3m f of x dx. So it can be written as 3h by 8, and it is f naught plus 3 f1 plus f2 plus f4 plus f5 and so on f of 2m minus 2, not 2m but it is 3m minus 2 plus f of 3m minus 1 plus f3 twice of f3 f6 plus f of 3m minus 3 and plus f of 3m. This is the formula for Simpson's for the Simpson's 3/8 rule, right? So and here what is h? Here h is basically, it is x n minus x naught over n. It is basically the value of h. This is the way it can be evaluated, right? So this is all about it. Now let us try to evaluate the integral of sine x. Let us call it as integral. It is from 0 to pi dx, and here let us take n is equal to 12. So when we take n is equal to 12, so taking n is equal to 12, and here we have chosen n is equal to 12 such that this 12 is multiple of 2 and it is also multiple of 3. This is also suitable for Simpson's 1/3 rule, and this is suitable for Simpson's 3/8 rule, right? So that's why we have taken 12 in such a manner, so that it is suitable for both Simpsons 1/3 and the Simpsons 3/8 rule also. So now let us evaluate the value of h now. So h is basically pi minus 0 by 12. So it is pi by 12 which we have taken. So now our objective is to find out f naught, because fx is given to us. Fx is basically, it is the sine of x. So let us try to find out this f naught, then f1, f2, f3, f4, f5, f6, f7 and so on, f8, f9, f10, f11, f12. So f of so this is sine of 0, it is 0, and it is sine of pi by 12. It is nearly equal to sine of 15 degree, and its value will be 0.2588. Then sine of 2 pi by 12, and its value will be sine of 30 degree, and it is 0.5. Then sine of 3 pi by 12 is equal to sine of 45 degree, and it is nearly equal to 0.7071. and similarly sine of 4 pi by 12, it is a sine of 60 degree, it's equal to 0.866, and it is sine of 5 pi by 12 is equal to sine of 75 degree, and it is 0.96. Its value will be 0.9659. Then sine of 6 pi by 12, and it is equal to sine of 90 degree, and its value will be 1. Similarly sine of 7 pi by 12 is equal to sine of 105 degree, and its value will be 0.9659. and now I can evaluate f of this f8. So it is sine of 8 pi by 12, and it is sine of 9 pi by 12, sine of 10 pi by 12, sine of 11 pi by 12, and sine of 12 pi by 12, or it is sine of pi or sine of 180 degree, and its value will be 1. And here it is sine of 120 degree, it is sine of 135 degree, it is sine of 150 degree, and it is sine of 165 degree, and sine 120 is 0.866, and its value will be 0.7071, and its value will be 0.5, and its value will be 0.2588. So thus we have evaluated these different values, right? So now we will use these values to, in what we call in the trapezoidal rule, Simpson's 1/3 rule, and Simpson's 3/8 rule. So these all are the values which we have to use now. So let us now apply these values, or substitute these all the values in Simpson's trapezoidal rule, right? So first of all, let us talk about the trapezoidal rule. So this is the first part which I am going to do it here. So integral I, it is 0 to pi sine of x dx, and it is equal to h by 2. It is f naught plus twice of f1, f2, and so on, f of 11 up to plus f of 12, right? That's what I am getting here. Here at the value of h will be pi by 12, and it is 1 by 2. Let us put their values. So it is 0 plus twice of 2 into 0.2588 plus 0.5 plus 0.7071 plus 0.866 plus 0.9659 plus 1 plus 0.9659 plus 0.866 plus 0.7071 plus 0.5 plus 0.2588 plus 0. These are the values which we are getting, and it is 3.14 divided by 24 into 15.912, and its value will be nearly equal to 1.9875. so this is the value of the integral which we are getting, right, using trapezoidal rule. But if we try to find out its integral, so its integral of sine x dx 0 to pi, it is equal to minus cos x, and its integral from 0 to pi, so it is cos of pi, minus cos pi minus cos 0, and it is minus 1 and minus 1, so it is minus 1 minus 2, so it will become plus 2. So this is the actual value of this integral, right, and this is the estimated value using the trapezoidal rule. Now we will try to find out its integral, again the same integral using Simpson's rule, Simpson's 1/3 rule. So let us try to do that. So now I will use Simpson's 1/3 rule to find out the same integral. So the integral will be 0 to pi sin x dx. This integral will be equal to 3h upon a, and here it is f0 plus 3f1 plus f2 and so on up to f of 11 plus twice of this is not the Simpson 1/3 rule, but let me correct it. Yeah, it is h upon 3, it is f of 0 plus 4 times f of 1, f of 3, f of 5 and so on, f of 11 means all odd terms, and then twice of the even terms, f of 2, f of 4 plus and so on, f of 10 plus f of 12. So that's what we are getting here. Let us substitute their values and then we will get the result. So it is 1 by 3 pi by 12, and its value will be f0 will be 0, f0 will be 0 plus 4 into the value of f1 will be 0.2588 plus 0.7071 plus 0.9659 plus 0.9659 plus 0.7071 plus 0.2588 plus 2 into it will be 0.5, and then 0.866 plus 1 plus 0.866 plus 0.5 plus 0. These all values which I substituted, and it will be 3.14 over 36. 12 3 is 36, so into and if we sum up all these values, then it is 22.9064, and it is equal to 71.926 0.096 divided by 36, and this value will be nearly equal to 1.99794. so this is the value which we are getting from the Simpsons 1/3 rule. Now let us talk about that how the same integral can be evaluated using Simpsons 3/8 rule. So let us talk about it now, right? And I is equal to 0 to pi sin x dx 3h upon 8 is f naught plus 3 f1 f2 plus f4 plus f5 plus f7 plus f8 plus f10 plus f11, right? Then plus twice of f of 3 plus f of 6 plus f of 9 plus f of 12. It is 3 into 3 by 8 into pi by 12, and inside it let us put their values. 0 plus 3 into 0.25 plus 0.5 plus 0.866 plus 0.9659 plus 0.9659 plus 0.866 plus 0.5 plus 0.2588 plus 2 into 0.7071 plus 1 plus 0.7071 plus 0, and it is 3.14 divided by 32, and if we sum up all these values then it is 20.3726, and it is nearly equal to 1.99906. So this is the value which we are getting. Now let us compare the results, all the results, right? So actual value is this one. Its integral of sin x dx 0 to pi, its value will be 2, and its value 0 to pi sin x dx, its value comes out to be 1.9872, and 0 to pi sin x dx, its value will be 1.99794. so here it is actual value. This is from Trapezoidal Rule, and this value is Simpson's rule 1/3, right? 0 to pi sin x dx is equal to 1.99906. Simpson's rule, it is 3/8 rule, right? So if we compare these results, then the trapezoidal rule is far away from the actual value, but Simpson's 3/8 rule is more closer to the actual value. Thus, as we move from trapezoidal rule to Simpson's rule and then Simpson's 3/8 rule, then we are moving towards the more accuracy, but they will take more time consuming, right? So that's all for this lecture.